Okay, everyone, I promised I'd make a video on the worksheet where we did quadratic word problems on Friday, and your classmate was absent that day, so I thought it would be a good idea just to do at least one of the two problems that we did in class together. And even if you've seen it before with me in class, it's worth watching again for all the little details I share with you. So please pay attention, and like most of my videos, I recommend you watch this multiple times if you can. But we'll just go ahead and do this problem number 1 here again. Notice we're told we have this guy named Jason, and he's jumping off this cliff in Acapulco. And as he's jumping off, the height of Jason is actually determined by this quadratic here, as you can see, h of t. Now, h is the number of feet high from the water, and the time is measured in seconds. And we're supposed to find the maximum height that he goes, the time for him to take it there, anyways, to get to that maximum height. And we're also supposed to find actually the actual highest point, maximum height he reaches. And also, of course, we want to figure out how long it's going to take for him to hit the water. So, how are we going to do that? Well, one thing I want to remind you of, guys, is you wouldn't have to do this on the final per se, but I want to make sure you understand that this equation right here, every part of it means something. So, for example, let's say here's the cliff, here's the water below us, and here's Jason right here, right? And, of course, he's about ready to jump off this cliff and go into the water, right? So, what does the equation tell us? Well, for example, this 480, this constant, that tells us something alone. That tells us that Jason right here is actually 480 feet above the water. In other words, we just figured out how tall the cliff is, at least from where he's standing. So the cliff is 480 feet tall. What else does this equation tell us? Well, the 16t tells us the initial speed that he's jumping out at. And in other words, what we just figured out actually is that Jason, he just didn't jump straight out and then down. Okay? Because there is a speed there, what we know now is that Jason actually jumped out, or up, I should say, and then, of course, fell down into the water. And this initial speed going up here is at 16t, or 16 feet per second in this case. Finally, what may be perhaps the most important thing is, what is this negative 16t squared? Guys, that's the gravity. Okay? Remember, what's going to cause him to fall, just like any of us falling, would be gravity, right? The Earth's gravity is pulling Jason down right here, right? That gravity is pulling him down. Now we know it's going to be at negative 16 feet per second squared. And that, by the way, guys, is what gravity is. And why it's negative is because it's pulling us down. Okay? But anyways, let's go ahead and get to the problem here. So, the first thing we could do, for example, is since we want to know the maximum height, which is going to be right there, how do we find the vertex? Remember, the maximum height is going to be at the vertex. So to find the vertex, let me actually go to a new page here. So to find the vertex, please remember that to find the vertex, you simply do negative b over 2a. The same formula we use to set up our table, because remember, the vertex is what I always refer to initially as the middle number of our table, but it's actually the maximum or minimum point. In our case here, this is what we would refer to as the maximum point, right? That's the highest that he's going to jump to before he falls to the ground. So, Let's go ahead and do negative b over 2a. I'm going to do the negative of 16 over 2 times negative 16. And again, let's just verify that. We know our b is 16. That's the number or coefficient of the t in this case. And the t squared coefficient over here is our a, right? Negative 16. Okay, so if you do your math correctly, we'll have negative 16 over negative 32. Some of you would want to simplify here, actually. But any way you do it, you're going to end up with positive 1/2, better known as 0.5 seconds. So we just figured out it took him 0.5 seconds to jump or reach the highest point he's going to be in the air before he falls down into the water. And so that's basically the answer for question A. Now, we also want to know the actual height of it. So how are we going to figure that out? Well, let's go back to our equation, h equals t. So this is problem B here. What's his actual height 0.5 seconds later? Well, again, the formula goes negative 16t squared plus 16t plus 480, right? And we're going to plug in that 0.5. And again, I suggest you use your calculator. And remember to use parentheses when you plug in those values. So as you can see, I'm plugging in 0.5 seconds for t because we figured out up here again that that's how long it took to reach his maximum height. And again, guys, I suggest you do that on your calculator. And what you're basically going to get is what I have graphed here. So what you're looking at here, guys, is the actual top part of the parabola. It's so skinny here just because of the negative 16 in front of the t squared. Our a being negative 16 means it's going to be a stretched parabola. Okay? I accidentally messed up there a little bit. Let me just clear the ink from the page there. Okay, so as you can see right here, we know it took them 0.5 seconds to get to the maximum height right there. And the height that he's at is 484. And that again is what this is going to turn out to be if you do it correctly on your calculator. So what have we figured out now? We know it took him 0.5 seconds as he jumped off the cliff to get to his maximum height. And we figured out his maximum height is 484 feet. Finally, we come to question C. Question C said, at what time will he hit the water? Well, let's go back to our original equation one more time. And to figure out when he hits the water, well, how tall will he be, or how far above the ground or water will he be when he hits the water? Well, the answer is 0 feet, right? So let's say on the final, instead of 0 feet, they say, hey, when is he going to be at 100 feet above the water? Well, guess what? Plug in 100 and solve it. If the question said, at what time will he be 250 feet above the water? Plug in 250. And then you're going to have to solve this, right? Set it equal to 0 and solve it. But anyways, let's go ahead and solve this. We know 0 is when he hits the water, right? And as I recommended in class, guys, before you try to do the quadratic formula here or factor it like we learned in class, let's try a GCF first. Greatest common factor. In our case, guys, we can divide all of these numbers by negative 16. So that's what I'm going to do. Now, why am I doing a negative, by the way, right here? Is because I want that t squared to be a positive. It just makes it easier when I factor. So when I take out, follow the green here, or blue. When I take out that negative 16, which is right here, I'm left with, of course, t squared. And when I take this 16 and divide by negative 16, I get a negative 1 t left over there. And then finally right here, when I divide that by negative 16, it's going to be a negative 30. And if we know it equals 0, look how easy this is to factor here, guys. I'm just going to go t times t. We know it equals 0. I know 6 times 5 is 30. Now, why did I use 6 times 5? Because to get this minus 1, I'm simply going to do minus 6 plus 5. And we can solve this now. This right here would be 6 seconds. This right here would be negative 5 seconds. Now, in reality, can we go backwards in time? No. So our only logical answer, therefore, is 6 seconds. And if you notice, this part of the graph, now this is the bottom part of the graph, guys. Notice here is the x-axis. Everyone see the green I'm marking there? That's where it's 0, as you can see by the point y coordinates there. But notice, guys, according to Desmos, it was supposed to be, this is him basically here falling down into the water, right? And you can see he's going to hit the water right there at 6 seconds, as we just calculated. Notice they have the negative 5, but again, that doesn't matter in our context, in the context of the problem, since we can't go backwards in time. So again, here are the answers. We know it was 0.5 seconds, and then he reached the 480 feet for his maximum height. And we knew it took him 6 seconds to hit the water.